Okay, so now we're going to just talk about what we call equivalent expressions. So equivalent expressions, you learned about expressions a moment ago, right? I'm going to just make a trinomial here with three terms. So let's go. It's 3x minus 2 plus 4x. Okay, so this is a trinomial. So that's because it has 1, 2, 3 terms. These terms here are also products, right? Because they have a coefficient and a variable, and they're being multiplied. So we have products that are terms, okay? Now what we have is a trinomial, and it's kind of, it looks like maybe we could simplify it. So what happens is, let's pretend that the x, remember in algebra, these symbols can mean anything. So let's pretend that these x represent, I don't know, we'll say x is the number of bananas, right? I don't know, it's some quantity of bananas, so it's a bunch of bananas, right? So now here I have 3 bunches of bananas, right? And now I have 4 more bunches of bananas that are going to be added in. And then in the meantime, I'm taking away 2 something else. Okay, 2 something else. So if this was an expression talking about, let's say, weight, so then these bunches of bananas would have a weight, right? So maybe it would be like, the bunch weight, well, let's just say 3 pounds. X is a pound of bananas, right? So in my bag, I have 3 pounds of bananas, and I'm adding 4 more pounds of bananas. I'm taking out 2 pounds of something. So this is 2 pounds of something. So how much is that all together? It would be a lot simpler if I could, instead of talking about bananas 2 different times, if I could combine them. And it turns out that you can, right? And that's because of a property called the commutative property. And this one is a property not of equality, but it's of addition. So what that means is that if I have 3 plus 4, right? This is the commutative. So what do commuters do? Commuters go to work and back, right? They drive one way, then they turn around, they drive the other way home. Well, commutative says I could go 3 plus 4, or guess what? I could turn it around, and I could go 4 plus 3, just like a commuter. Go to work, come home. Go to work, come home. So here we're going to switch around from 3 plus 4 to 4 plus 3, and these 2 expressions are equal to each other. They are equal, or what we call equivalent expressions. So is there an equivalent expression here that we can come up with to this trinomial that's maybe a little simpler, that we can simplify, right? We want to simplify using this property. Well, sure, I could go 3x plus 4x minus 2. Because of the commutative property of addition, all of these things can be moved. And it's really important when you see that minus 2 that you realize that is actually plus negative 2. It really means plus negative 2. We really remember that the term is negative and all terms are being added. And that makes it to where I can move this negative 2 to the end and bring the 4x forward. And now we can do something that we call combining like terms. So these 2 are like terms. It's exactly the same thing we're talking about. Here I have 3 pounds of bananas or whatever. This is 4 pounds of bananas. So together I can add them up because it's the same quantity, and now I have 7 pounds of bananas. So they can be combined. That's how we combine like terms. So now we have a simplified. Can I combine these 2? No, because this is 7 pounds of bananas and that's 2 something else, right? It's not the same thing. So, but what we have is we have these 2 expressions, 3x plus negative 2 plus 4x, and we're going to say that it is an equivalent expression to 7x minus 2. See why we call this simplified? So that is how we do simplification, right? In algebra. We can simplify by combining like terms, and what allows us to do that first is using the commutative property of addition. Okay? Now, I'm going to show you a second example here, and in this example, we're going to use a different property to simplify. Okay, here I have another expression, has 8x minus 28 over 4, which means this is the numerator is being divided by 4. So there's a few things we can do here, okay, to simplify it. And the first one I'm going to do is I'm going to work on distribution. And the property, the distribution, we call this the distribution property of multiplication. Okay, multiplication. So that means I'm going to look for a common factor out of 8 and 28. I'm going to factor it out. This is a process called factoring, right? So I'm looking for our greatest common factor or greatest common divisor of those two terms. So I have 8 and 28. So let me make my list of terms for 8. 1 times 8, these are my factors for 8, and 2 times 4, and those are the only ones really that I can come up with. For 28, 1 times 28, 2 times 14, 4 times 7, and that's all I've got there. So now I'm looking at these factors, and I'm looking for the factor that is the largest that exists in both of them. Well, 28 is the largest, but it doesn't exist over here. 14 is next largest, but it doesn't exist over here. 8 is the next largest, but it doesn't exist over there. 7 doesn't exist over there. And 4 is my greatest common factor. So I'm going to pull 4 out, right, to the side. And then I'm going to say this is a greatest common factor, also known as the greatest common divisor. And that's because we can divide both of these numbers by 4. So if I want to figure out what that is, I go 8, and I'm going to divide it by 4, and 4 goes into 8 2 times, and the remainder is 0, right? So I can say that 4 times 2, which we know right here is the case. So if I pull 4 out, if I take 8 and I divide it by 4, I take this expression, 8x minus 28, and I would rewrite it by pulling the 4 out. I think of this as 4 times 2x, right? But I'm going to pull the 4 out. And over here, this is 4 times 7. 28 is the same thing as 4 times 7. So I'm going to put minus 4 times 7. And I'm going to think that I want to pull the 4 out to the side of both of these terms. So I'm going to write it outside. And then I'm going to make a parenthesis. So what goes inside these terms? Well, everything that's left. I have 2x, right? And I have minus 7. So that's what's left inside of the parentheses with the 4 on the outside. Now, why would I do that? Why do I do it? Because I've got a 4 in my denominator. And now we think about what these operations mean. This means take this factor, this is a product, right? And this is a difference right here because subtraction. So take this factor, this difference, and it is a factor, and multiply it with this factor. But then divide it by this, and what we have, this divisor and that factor, they are equal. So if I'm going to multiply by 4, which means create 4 parts of this, and then divide it by 4, which is cut it back down 4 parts. So these two things, these operations cancel, and now I have 2x minus 7. And this is an equivalent but simplified, equivalent but simplified expression of that. We like this better than we like that. So this is using the distributive or distribution property of multiplication to factor, right? And then once we factor, we can simplify. And now I'm going to take a minute and show you how to use technology to do the same. Sorry, I said I was going to use the technology. That's actually scheduled for the next video. So you can stop watching this now.